Hello Dave, I thought I'd make a short video and explain to you what happened with your transformer. So if you look at the upper diagram, you've got the transformer, that's the AC coming in, and through the transformer going out to a center tapped to output. I've drawn in 230 volts. I don't remember what the actual voltage was there, but this is quite typical of radio receivers that I've worked on. So you've got two windings coming out and the center tapping taken to ground, and then between ground and each winding you have 230 volts coming out. Now if you imagine this as being two coils sitting on top of each other, each coil has a relatively low, let's call it impedance, across itself, which would mean that if you put a very high impedance meter across here, there'd be very little load across the coil, which would have very, very little effect on the effective voltage being seen at the output of the coil as you put the load on it. As you increase that load, this voltage begins to come down. I'm sure that part makes quite good sense to you. So let's move down to the second part. Now what happens, especially in these type of radios, when you have bad capacitors in the coupling stages of the preamp and the audio amp, and it starts to bias the tubes, the preamp tube and the power amp tube hard, it starts to suck a lot of current out of the power transformer. So inevitably what happens is, with time, the windings inside of here get hot, and they start to burn out, short together, they become resistive, and they lose their value and can possibly even go open circuit. I've had some going open circuit, and this can also happen in the audio transformer as well. So what happens? As this resists, you had the scenario where the one side was good and the other side was bad. So this section over here becomes resistive with heat, with overloading and so on. And this resistance becomes a higher impedance. Now, when you have a higher impedance, if you have an extremely high impedance meter like a VTVM measuring the output of that coil to ground, then you probably would still see 230 volts. But you use the digital multimeter, which is normally around 10 mega ohm input impedance. If that impedance was higher, let's say that impedance was 100 mega ohm, which is probably what it was. First of all, it's not measurable on the standard DMM. Only a mega would be able to pick that up. But second of all, as this voltage gets developed over that thing, it would, because there still is actual continuity, even if it's a high resistive continuity. Let's assume for a moment that there's absolutely no load. Then theoretically, even though this part here is resistive, you would still have your 230 volts across there because your windings were still somehow intact. But because of the high resistance, you're getting a very large voltage drop across here, and then your relatively high resistance of your meter provide the rest of the resistance. So effectively you've got a resistor here and a resistor there going to ground, which is a voltage divider. And that's why you've got that 180 or whatever it is, 190 volts reading on your multimeter. If you'd gone with a VTVM, you would actually have probably seen 230 volts because of the extremely high input impedance. 20, 30, 40 mega ohms, you would have seen closer to your actual rail voltage. Your VTVM, and the only one that would have measured anything lower would have been a modern analog multimeter that would have pulled this voltage down even further. And then, as you rightly saw, the best thing to do is put a direct load on it and watch that voltage take a dive. You know, when you fitted your tubes and so on. The thing is that it's still being held up by the other side of that voltage, because these two voltages are going to eventually come together at the output of the tube. Anyway, that's an explanation of what happened with your transformer. I've actually had this happen to one of mine as well. So I hope this is useful for you. And thanks for your videos. They're really great. I enjoy watching them. Very detailed and thoroughly entertaining. Your restorations are marvelous. Cheers now.